So I'm going to talk about positivity and representations of surface group. And this is a joint work with Olivier Guichard and Anna Winhart. So I guess you have some ideas of what representations of surface groups are. It just mean that you take the fundamental group of a surface of a closed, connected, oriented surface of genus G, G greater than 2. This kind of a duck which I drew in the previous lecture. Then I want to talk about positivity. So positivity is both an old and very old and very new structure. So I'm going to spend some time describing it. So I need to introduce a little bit. What are flag manifolds? So you start with a semi-simple group. So I learned semi-simple group from Yves Lenoir, and he always told me that semi-simple group, you just have to think of SLNR, and everything that's true for SLNR is essentially true for any semi-simple group. So if you don't want to hear more, think of SLNR. But in this talk, since I will have to go into the finer structure of flag manifold, I will have to consider other objects. So for instance, another example would be SO2N. So that's a group of isometries of a metric of signature 2N on the Euclidean space, on Rn. And the other group which I will consider is a group, the symplectic group, which is a group of a transformation of R2N, which preserves a symplectic structure, okay, a linear symplectic structure. So now let's move to the definition of a flag manifold, or it's actually called a generalized flag manifold, but we're going to stick to the definition of flag manifold to make things simpler. So a flag manifold is a space X with the following property, a topological space X with the following property. So the first thing is that X is compact. Okay. The second thing is that G acts transitively on X. So it turned out there are lots of homogeneous spaces which are compact and on which G acts transitively. For instance, for SLNR, there is a sphere, okay, Sn, but there is also, I mean, the projective space, but there is also a G mod gamma, right? You take a uniform lattice, G mod gamma, that's definitely a compact space on which G acts transitively. So to distinguish the flag manifolds, I have to add an extra property, which is a dynamical one. So what is this dynamical property? Is that there exists just one element of there are several, but there is at least one element of G, which acts on X, of course, but this element has exactly one attracting fixed point, meaning that, I'm sorry, this is the attracting fixed point that is nearby here. You see that this point here is going to end up at this point S. And you have one attracting fixed point, and you also have one repulsive fixed point, and this goes here. And so that's the dynamical definition, which I like because it's very convenient. But there is also a very useful algebraic definition, which is in principle, but you need to know more the algebra than what I'm going to need in that talk. And the fact is that X is going to be G mod P, where P is a parabolic subgroup of G. Now, let's give a geometric definition of positivity. So you say a flag manifold admits a positive structure if one can choose in a G equivalent way specific components of OX of the intersection of two Schubert cells, which I want to call diamonds, because I keep in mind this idea of this future of X and the past of Y to intersect in some object which looks like a diamond. And this, how do you characterize which diamond you want to take? Because which are the nice diamonds? They satisfy a nesting condition. This is a very important condition. So this nesting condition say that if you take X and Y, if you take Z in a diamond defined by X and Y, then there exists a diamond with associated to Z on Y on this diamond is strictly inside the diamond defined by X on Y. So now let's let's go back to positive quadrupoles. I said that we have to define what are positive quadrupoles. So what is a positive quadrupole? So first, x1, x2, x3, x4. So the first condition is that all subtriples are positives. So what is the property now of being a positive quadrupole? Right. So x1, x3, x4 is a positive quadrupole. So it determines a diamond so that x3 is inside that. So the condition about positivity of quadrupoles, then you require that x2 is actually inside this diamond. Okay. And furthermore, you require that the subdiamonds here is included in this big diamond here. And this small diamond here is included in the big diamond. And this diamond here, all the subdiamonds that you consider here are included in the big diamonds. So here is a definition of what is a positive map from sigma. So sigma here is a countable cyclically, a countable subset of S1 or a S1. It's any subset of S1. So you want to say that a map from S1 to my flag manifold is positive if it sends cyclically ordered quadrupoles to positive quadrupoles. So now you can define easily what is a positive representation. So you just say that a positive representation is a representation of a surface group into G is positive with respect to the positive structure defined on S, if what? If there exists a row equivalent positive map xi from the boundary at infinity of the surface, which looks like a circle, okay, and which is which is homeomorphic to a circle, to this flag manifold F. I should state here, so there's a theorem which is due to Goldman, which is that the space of holodomies of hyperbolic structure is, so you see that is a union, actually two connected components of the space of representation of this representation of pi1 of S into the group PSL2. Right. So what I want to say here is that this is the prototype of the theorem that we want to prove. So here's a result, which is the main result of this paper with Guichard, myself, on Anna Wienert, which is the following, that a positive representation is Anosov. So I'm going to explain a little bit what does a Anosov representation means. And more important, and that this uses this first property, is that the set of positive representation is a union of connected components of representation. So here there is an extra hypothesis, which say that they do not factor through parabolic by a recent result of Jonas Bayer Olivier Guichard, myself, Pozzetti, Beatrice Pozzetti, and Anna Finard. Then this condition is not necessarily anymore. So it turned out that the set of positive representation using this result is actually a union of cognitive components of representations without any extra condition.